Okay, good day, everyone. Welcome to today's presentation, 2024 NFPA 70E Major Changes, generously sponsored by GlenGuard. My name is Colleen Beatty, and I'm the senior editor here at Electrical Contractor Magazine. So on behalf of the magazine, I welcome everyone and thank you all for attending today's presentation. So before we get started, I just have a few quick housekeeping items. First, please note that today's presentation is being recorded and we'll be providing you a link once the webinar is over. So if you have to miss anything or you have to leave early, don't worry, you can come back anytime and watch the recording when it works for you. And of course, we encourage your participation in today's webinar. So please send us your questions. You can submit them at any time during the presentation using the Q&A module on the right of your screen. I'm going to highlight it for you now. And we'll have time at the end of the webinar to answer your questions. You can also use the Q&A module to reach out to me if you have any technical difficulties. Now, there's also a quick survey that should pop up on your screen at the end of the webinar, and we hope you'll fill that out. Or if you'd like to fill it out sooner, you can do that at any time. It's the little pink button. I will highlight that for you now. Just click that icon and open it up. And finally, we have an upcoming webinar on November 28th about the 2024 construction outlook, a little preview of our outlook. So please keep an eye out on your email in the coming days for that announcement, or you can visit ecmag.com right now for more information and a link to register. So with all of that out of the way, I'd like to introduce today's speaker. Please give a warm welcome to Jim Phillips. He's the founder of brainfiller.com, and he provides trainings like this webinar all around the globe. He's the vice chair of IEEE 1584 Arc Flash Working Group, the international chair of IEC TC 78 Live Working Standards, and a technical committee member of NFPA 70E. And you might also recognize Jim as the author of the Arc Flash safety column in our magazine. Welcome, Jim.
Thank you, Colleen. Thanks, everybody, for being here. Thank you for Electrical Contractor for being the host, and also GlenGuard for being the sponsor. So it's certainly my privilege to be here. I'm glad you all could make it. And yes, what I want to discuss are the major changes to NFPA 70E. We get to go through that time-honored tradition every 3 years of seeing what's new, what's the latest, and what's the greatest. I also have a little bit of housekeeping, and that is, as Colleen mentioned, I'm pretty far up in a lot of the standards organizations. So because of that, I'm actually obligated or required to state that what I'm going to discuss here is just my view, my opinion. It may or may not reflect any of the views of any of the standards organizations. So just to kind of, keep that separate, that this is just coming from me. And so with that, let's go ahead and take a look at this. Oh, one other thing I have is if you want to take a picture of this link that I'm showing right here, if you don't have a copy of the 2024 edition of NFPA 70E, NFPA has a free viewer. It's at this link, so you can go out here, and you can't, print or anything like that, the copy, but you can at least view it if you want to follow along or look at some of this later on. Also,
Jim, I believe I put that link in the resources box too for you.
Oh, perfect. And then, as Colleen also mentioned, yeah, I am a contributor to Electrical Contractor since 2009, I believe. And every 3 years, I have the privilege of writing the changes article for NFPA 70E. So the 2024 changes article you can find online, ecmag.com, and it's in the May 2023 edition. And there I go through basically the text version of a lot of what we're going to talk about here. So a lot has happened since 2021. Going from 2021 to 2024, we had 357 public inputs. Think of those as like proposals, and they come from people like you. They come from people in the industry. That led to 166 first revisions. We met, got together, went through all this. First time ever, we did it all online because it was right in the heart of the pandemic. And then we got together to review 168 public comments. That was in Kansas City. And that led to 73 second revisions. And these all came together to give us what we now know as the 2024 edition of NFPA 70E. One of the things I like to say is 70E now, in my opinion, has become a pretty stable document. In the earlier years, there'd be some pretty sweeping changes. Let's try this. Well, no, let's do that. And it's pretty pretty stable, as I would refer to it right now. There are some changes, some additions, which we're going to talk about. And some of the changes are just to conform with what's known as the NEC style manual. That the NEC style manual has certain requirements for formatting, for text, for things like that. So I'll point those out as we go along. One of the first changes is with every revision, there'll be what are referred to as global changes that just ripple throughout the entire document. And one of those changes is changing the word shock to electric shock, because we had shock, that's historically what's been used, but is it like, whoa, I'm shocked? Or is it this kind of shock? I wouldn't advise doing something like that. And so the word electric was changed to shock, or not changed, but electric was added to shock. And the only exceptions, there are still 2 places where you'll see the word shock and electric is not in front of it. And that's when we're talking about a shock wave. So the hearing protection boundary, the lung protection boundary, both use the word shock, but they're referring to shock wave. Everywhere else, it is electric shock. And this actually occurs 63 times in the 2024 edition of NFPA 70E. Another global change was we referenced the word leather protectors. And the word leather was deleted from this because the ASTM standard just refers to protectors. And actually my work in the IEC global standards, that's also the term that they use, because not all protectors are exclusively going to be leather. So in order to sort that, it's now just referred to as protectors. Another thing that happened, and this is with the NEC style manual, is every article is required to have a scope. Believe it or not, they didn't all have scopes. And so scope is always going to be .1 of each article. Now, there were 11 articles that did have a scope. So you have like 110, 120, 130.1.1.1. But there were quite a few articles that did not. So these are the articles where new scopes were added. And what that created is there had to be some renumbering, because all of a sudden you're shoving a .1 in there and everything else had to ripple on down. You'll see that in some of these, a little bit of reorganization. Article 90, the introduction. The change here was, okay, the introduction of scope. There was a scope in the 2021 edition, but it wasn't a .1. So simple enough, that was moved to .1. And the scope also had a lot of material in it that really didn't need to be in the scope. It was about what's covered or what's not covered with NFPA 70E. So that got its own section. So we now have the organization scope, purpose, and then workplaces covered and not covered. That was extracted from the scope. So just a bit of reorganization for this. The explanatory material, this was really long overdue. I think it was kind of understood by a lot of people, but if you don't put it in writing, how are you going to enforce it? And that was about if there are standards that are referenced within NFPA 70E, sometimes they will list the edition, sometimes they don't. And as an example, IEEE 1584 is referenced in NFPA 70E, but it didn't say which edition. I think most people would think, well, it'd be the latest one, wouldn't it? It should be, but that wasn't really clear. So now what we have is there's language that states that if the date is not provided, it's implied that it'll be the latest edition to be used. Article 100, definitions. So definitions had historically been in .2 of each article. And a lot of these definitions have been migrating to Article 100, but now there's a requirement that all definitions go to Article 100. The way this was done before is if there was a definition that was exclusive for one article, then it could remain in that article. That article's number .2. But now that doesn't even fly. All definitions have to be in Article 100. So everything in the 310, 2030, all of the basically Chapter 3 that were unique to just those articles, those have all been relocated to Article 100. There's a scope change, and the scope talks about these definitions that if they still only apply to one article, then there's going to be that article in parentheses. So it's going to look like this. For example, we have the definition for battery effect. This was in 310.2. Okay, well, it had to move to Article 100. So it's now in Article 100, but you have the article the one and only article that it applies to in parentheses. And then electronic searching. So NFPA has their standards online. It's a subscription-based service. And if you're searching, it can be a little difficult because of the way the definitions are provided. So for example, you have the definition for arc flash boundary, except it's listed as boundary, comma, arc flash. So it'd be like somebody referring to me as Phillips, comma, gem. It's like, that's not how people refer to this. So in parentheses, you also now have listed the common format for the term, just for electronic searching. The protectors, which used to be leather protectors, the definition was slightly revised here, that it's a glove or mitten to be worn over the rubber insulating gloves. Those are some of the main things that happened in the definitions section. Now, Article 110 and NFPA 70E, I know probably a lot of you are somewhat familiar with it, or a lot of them are really familiar with it. It's really well organized. There are three main chapters, Chapter 1, 2, and 3. The bulk of the requirements fall under Chapter 1, and Chapter 1 is broken up into 100 definitions, 105, which doesn't have a whole lot in it anymore. But the main parts of this are Article 110 and 120 and 130. And that's what I want to talk about. I'm also going to talk about a few changes that have occurred in Chapter 3 and a new edition of another informative annex. So a lot of major things have happened. So as far as the 110.1, there's a scope. A new scope just simply states this article covers the general requirements for electrical safety-related work practices. Now, some of you may remember back in 2021, Article 110 had a major reorganization. I mean, it was just, draw a flow chart. This went here, this went there, this was consolidated. And in hindsight, looking at it, it was a little complicated. So things were cleaned up a little bit this time around. And what happened is 110.1, which is priority, the single most important part of electrical safety, that had to get moved around a little bit. And scope goes to 110.1. So we have the original priority, and we have the electrically safe work condition policy. Those were merged together, and they're just called policies. So we have everything falls into 110.2 now, this main part of it. 110.2, we have A, the policy, and then these were brought together for B. When is it required? When is an electrically safe work condition required? So we have the policy, we have when it's required, and then we have requirements until you establish it. So a lot of the intent is still the same, some of the text is still the same, but there was a reorganization. So the electrically safe work condition, A, remember I said everything's in 110.2, so we have A. A just simply states you have to establish a policy that does item 1 and 2. Okay, what are those? Well, number 1, this is where the hazard elimination comes in. It's still ranking first. We had to have the scope, but you get past the scope and hazard elimination, that is always the first priority. Eliminate the hazard. Second part of this is, okay, so you eliminate the hazard, then there's a reference, okay, it's got to comply with what's in B, 110.2B. Well, okay, what's in 110.2B? Well, let's take a look. When is this required? It's required when you're working on systems 50 volts or greater, and that aligns with OSHA as well, and the employee is working within the LAB. LAB is limited approach boundary. What that means, that's defined in NFPA 70E, that if someone has exposed energized parts, there's a boundary where unqualified people have to remain back. So if somebody gets within that boundary and the parts are exposed, that is going to trigger the electrically safe work condition, or if there's interaction in such a way that may result in an arc flash. Interaction was actually introduced back in the 2009 edition of this. The policy must have hazard elimination as the first priority, and then it defines when this is required. The priority, as I said, it was first introduced in 2018. First priority, eliminate the hazard, and it's been there since 2018. It just keeps getting moved around. It used to be in 105, then it went to 110.1, the very first part, but then it had to get bumped a little bit since 110.1 is now going to be the scope. Informational note was added that the electrically safe work condition policy could be part of an employer's management system, just ways to document it as an informational note. And then 110.2b hasn't changed a whole lot, but the titles, the numbers, things like that have changed. So what 110.2b actually says is energized conductors shall be put into an electrically safe work condition, 50 volts and greater, before anybody does any work, if they're within the limited approach boundary or they interact. So this is what you would have with the limited approach boundary. Exposed energized conductors. Okay, well, there's a hazard there within the limited approach boundary. Interaction, the concern is if there's interaction, what if it results in an arc flash? You might think just switching a device, that's interaction. Technically, yes, but NFPA 70E has a checklist on when is an arc flash hazard likely. We're going to see that here in a little bit. When required, whoop, the famous exceptions. So yeah, in general, you establish an electrically safe work condition, but there are exceptions. And many of the exceptions already existed. They were just relocated. But a couple of exceptions are new. Normal operation of electric equipment, that was there. It was relocated. Disconnect means of isolation for isolation. That's new. Infeasible, that was moved. That's been around. If it increases or introduces a hazard, if de-energizing introduces an additional hazard, that's been moved. And less than 50 volts, except the less than 50 volts now has a reference to you have to make sure that there's not sufficient energy that can cause burns or explosions due to arcs. So a little bit of a change there. Normal operating condition, this is what we had back in 2021. And we had 6 items, check the boxes. So if the equipment is in a normal operating condition, it was thought, okay, there's not really much of a risk of an arc flash hazard. And so checking the boxes, has the equipment been properly installed, properly maintained, used in accordance with the instructions, equipment doors closed and secured, covers in place, no evidence of impending failure. And that's what we've had. We have a relocation. This is now an exception. So the 6 boxes to check are still there, but they're part of an exception, and we have a 7th item. And the 7th item is to make sure that the equipment is rated for the available fault current. Rated for the available fault current. How did that get in there? Well, think about it. You're operating equipment. If something goes wrong, if the equipment's not properly rated for the fault current, that could end badly if a fault occurs. So that was added. It was actually added as the 3rd item. So we still have the original items and the available fault current that got pushed in there at number 3. So the available fault current, I mean, it's actually a requirement anyway. The National Electrical Code, which is what this is from, Article 110.9, 110.10, requires that the equipment is rated for the available fault current. So in NFPA 70E, that is in there as well for normal operation. The electrically safe work condition, the exception, the 7 items that we have right now, there's always been this question about item number 7, no evidence of impending failure. How do I know? Well, it's more of an observational thing, or if you've conducted testing and you find something that makes it a little suspect. But there's also been a question about what if the equipment's been like exposed to water, or it's in just really, really bad condition. I took this photograph years ago. This was actually, I live in Arizona. This is at one of the border towns from some time ago. But the thing about the water that I was talking about is, what if equipment has been exposed to water? Now, NFPA 70E, there are a lot of people that are from like the gas and oil industry on there, or several people, and they're around the Gulf states, which are prone to hurricanes. And I've heard the stories over recent years about, oh yeah, our switchgear, man, it was submerged. What do you do? Well, I took this photograph too. What do you do? This one really puzzled me. This was in Austin, Texas, at the Circuit of the Americas, the F1 track. I'm a big F1 fan. And this was from several years ago. A hurricane had just rolled through a couple days before. And I'm looking at that and it's like, who would have located electrical equipment in the middle of a drainage ditch? But anyway, that's what they have. So anyway, there is an exception number 2, that references whoops, I got ahead of myself here. Sorry about that. So there is a new informational note that references a standard for evaluating if there's been water damage. Another exception, and this is just really kind of clarifying something, is about the device that you're using to isolate. So you open up a switch to isolate part of an electrically safe work condition, and you may think, well, that's interaction, isn't it? So do we need to open up the switch ahead of it because we have interaction? And then like, oh, so then you open that, you open the one ahead of it. Anyway, so there's been a clarification that if you're opening a device to isolate the circuit, you don't have to open up the device ahead of it in order to interact with the one down below it. Yes, apparently somebody was thinking about this. Equipment operating at less than 50 volts. There was additional language added here, and this was about you have to determine that there's no increase in the exposure to electrical burns or explosions. Less than 50 volts, can there be an explosion? Never say never. I've never seen it happen. Can there be a burn? Oh yeah, you get sparks and things like that at less than 50 volts. Absolutely, there could be a minor burn injury. And so that's what this is about. Just make sure that you don't have something like this that results. The electrical safety program, job safety planning. So there was an item added to job safety planning. You include all the information, including an emergency response plan. If something goes wrong, you don't have time to like, oh my gosh, what do I do? So you have the plan set up ahead of time and you have it in place. So if something does happen, you have the plan to follow instead of making it up out of a knee-jerk reaction to a very bad incident. Yeah, this photograph here, this was at a place I was doing training a few years ago. This was a substation house. And opened it up and I saw that, and my first reaction was, because I didn't recognize or didn't register that it was a dummy. And it was like, oh no. And yeah, so anyway, the qualified person, this is really important. And I'll give you my reason why it's very important. I've conducted a lot of expert witness work over the years. And when someone is injured, one of my very first questions is, were they qualified? And I'll hear things about, oh, they've been here 20 years or whatever. It's like, no. Let's pull out NFPA 70E and let's look at what it takes to be a qualified person. And so I look at this as kind of a legal thing. And because of that, there are occasionally some fine-tuning, a bit of fine-tuning to the language. So for example, special was changed to applicable. I mean, what is special about special? So such persons should also be familiar with the proper use of not special, but applicable precautionary techniques, just tightening up the language. And also the word can was changed to shall because shall makes it mandatory. And so a person can be qualified. Nope, a person shall be qualified for certain equipment and tasks to be performed. Article 120, establishing an electrically safe work condition. So 110 defines the general requirements. 120 is really at the heart of this. Establish an electrically safe work condition, make the system safe. And there were a few changes here as well. The first change was just reorganization. Because we have a new scope, that meant everything else was going to be renumbered within here. And there was an addition about locating sources. If you have a circuit that could potentially have a neutral conductor still energized, depending on how the circuit is configured, you just have to be aware that, hey, the neutral could still be energized if you have multiple conductors in that circuit. Stored energy. Stored energy could be more than just springs, like a spring charge circuit breaker that could potentially reclose. And so a little bit of tightening up of the language here. Other sources of stored energy shall be blocked or otherwise relieved to the extent that the circuit cannot be unintentionally energized. And that's the goal. You don't want some other source of energy, pneumatic, spring, whatever it could be, that could cause a circuit to re-energize. The process for establishing and verifying an electrically safe work condition. This had a bit of a change to it. Step 7 in this, use an adequately rated portable test instrument to test each phase for the absence of voltage. That's where it's at. Until you've proven dead, you assume that it's energized. But there was some additional language added here. You test at each point of work. That wasn't in there before. It's like, wasn't that obvious? Well, again, if it's not in writing, how do you enforce it? So what this means is if you were going to be conducting work at panel PP1, down towards the bottom here, you test for absence of voltage at the work location. Testing up at MDP, I mean, you can do that if you want, but that is not going to qualify as testing for absence of voltage for work being performed down at PP1. Article 130, this is where a lot of focus happens, focusing on what do you do if we're going to be working around the electrical hazards. And you might think, well, we de-energize everything. We always make it electrically safe. That's fantastic. That is the goal. But the process of creating an electrically safe work condition in itself potentially exposes you to hazards. The shock hazard until you verified there's no voltage. The arc flash hazard until you verified, again, there is no voltage or no hazard there. So the one change here is, okay, of course, electric was added. So it's electric shock protection boundaries. And there were some changes here. The changes include the restricted approach boundaries. There was always this question, I'd receive it a lot. Why are the values a little different between NFPA and OSHA? Well, that was straightened out this round. And also, there were some rounding things that have occurred. And so there were some changes that were made due to rounding. So this is what we had in 2021. This was the table where you would determine the limited approach boundary, the restricted approach boundary. These are the numbers that we've had for a very long time. But now, a couple things have happened. The 751 to 15 kV was divided now, so it's into two different voltage ranges. And over here, the exposed movable conductor was rounded up. Mathematically, it was rounded incorrectly doing this, but electrically, it's the way to go. 10 feet was something like 3.04 something meters. And so the 0.04, yeah, mathematically you round down, but that means that we're giving up that 0.04. It's like, that's a distance we really shouldn't be giving up. So the decision was made, well, let's round it up. So we still have that distance and then plus a little extra because it was rounded up. And then the restricted approach boundary, these numbers were, some of them were changed to coordinate or synchronize, sync up with the OSHA values. There was also a note added, and the note is about the restricted approach boundary may need modified based on elevations. Let me elaborate on this a little bit. So this note is that the restricted approach boundary is based on elevations not exceeding 3,000, not exceeding 3,000 feet. And for higher elevations, you may want to consider adjusting the distance. Now, it doesn't say you have to. It's just kind of a, here, this is something you may want to consider. What's the big deal about this? Well, at higher elevations, the air density becomes less. Like I'm in the Phoenix, Arizona area, and depending on what part of the valley you're in, it's anywhere between 1,000 and 2,000 feet, not a big deal. You go up Interstate 17, and within 2 hours, you're in Flagstaff. That's at 7,000 feet. And then just a little bit beyond there, you're at the Snow Bowl, the highest peak, it's 11,500 feet. So yeah, we've got some pretty high elevations, and a lot of other parts of the country and parts of the world have higher elevations. So as the air density decreases, then that could change the dielectric strength of air. That's really what this is all about. The doors, it's somewhat known that doors may not offer protection in an arc flash. I've seen that a lot from a lot of my testing and arc flash work. But even though there was reference to the doors may not offer protection, that was actually in 70E, it was in the wrong place. It was buried in language about the DC side of things. So it's like, we really need to pull that out and make it common for everything that the doors don't necessarily offer protection. I mean, the doors might stay closed, but you never know. I have a couple of videos that I want to show you for this. This first one is some testing that I conducted a while ago. It's a small little bus plug, not that big. And well, let's take a look at it. Maybe. You there, Colleen?
It should be going now.
Okay.
Okay, let's go. 600 volts.
3, 2, 1. Fire in there.
And the door does not offer protection.
Yeah, I have a keen perception of the obvious. What it was, just the pressure, you don't know. Depends on the type of equipment. There is arc-rated equipment or arc-resistant equipment that's designed for the doors to stay closed, but that's a special design. I had another one, tested a motor control center, and you'll notice the upper corners, the doors are off. So you think, okay, pressure relief. Well, let's take a look at what happens here.
Okay, test 27, door closed. So much for the door being closed.
Blew the door open above it.
Yeah, got them both. Real
Is that
nice.
self-extinguishing or not?
It's going out, just smoke from the right section, but I think it's just
Coming up
exhausted.
together.
Yeah.
So, gee, okay. Do the doors off for protection? I mean, they might, but can't count on it because you never know. So, some other things I want to look at here, estimating the likelihood of an arc flash. There's a table for this, and the table, there's a change made just to the terminology. Instead of equipment condition, which is the middle column, that was changed to operating condition to sync up with other terminology within 70E. And it references the 7 boxes to check. Was the equipment properly installed, properly maintained? But just terminology just to get it to sync up with everything else. There was another kind of a clarification that was made that NFPA 70E says you're supposed to go back and review the incident energy analysis at intervals not to exceed 5 years, or if significant changes have occurred that could affect the results of the analysis. And people think, well, what could that be? What kind of changes are we talking about? Well, there could be a lot of things that could change the incident energy. The incident energy analysis is conducted based on equations from IEEE 1584. A lot of software will calculate all this for you. And the changes that 70E references, change in the transformer, modification of protective devices, changes to protective settings. And then one that I added, this one actually is not in NFPA 70E, utility reconfiguration or major substation additions. I added this one because in a past life, this goes all the way back to the 1980s, I was in charge of the transmission short circuit studies group for a really large utility. And I could see what happens firsthand. And short circuit current, that is a key component to how severe the arc flash can be. Now, the issue about that could affect the results of the study, I look at this as, does it affect the PPE? So if you have PPE specified for a given area of, let's say, 8 calories a square centimeter, and your study says, oh, it's well below that, like 4.5 calories, and somebody reviews the study and it goes to 4.8, 4.6, something like that, at the end of the day, so what? 8-calorie PPE still works. But if there's a change that pushes that PPE well above, that's a problem. And you need to go back and reevaluate what needs to be done there. As far as transformers, transformer sizes has a lot to do with this, and transformer impedance. So if you have the same impedance like I'm showing here, but different sizes, it affects the short circuit current. The 1500 kVA on the left, typical short circuit current would be around 30,000 amps. The one on the right, take it up to a 2500 kVA, short circuit current goes up approximately 50,000 amps. That could have a big impact on the incident energy. It can also have an impact on how a protective device operates. This is a time current characteristic of a circuit breaker. And with 30,000 amps, this is going to operate instantaneously. But if there's a change, maybe the current's less, it's going to take longer to operate. And the clearing time, from just my view, from being involved with this for a long time, the clearing time is the single most important variable. If you double the clearing time, the incident energy doubles. Or halve it, it's going to be halved. So I have a method. This is something I developed a long time ago. I wrote the first book on arc flash studies way back. And if you don't know what the short circuit current is from a utility, use an infinite bus calculation. And you might think, wait a minute, can't do that. That's not worst case. Infinite bus may not be worst case, but it might be. So use what's called an infinite bus, figure out the short circuit current on the secondary side of a transformer, run the study, and see what the calculated incident energy values are. And note, all the places where your PPE will be sufficient. And then decrease the short circuit current in incremental steps, 5%, 10%, something like that. And you'll see the incident energy come down and do it again and again and again. And you'll decrease it one time too many, and you see the incident energy jump. What happened? The short circuit current went down low enough that one or more protective devices is now in the time delay region, and the incident energy went up. So this is not a perfect answer, but what it does, it defines a range of source currents where your PPE would be sufficient, and then shows, okay, how low can this go before we start to have some problems. The configuration, this goes back to my utility days, that I was responsible for planning a transmission substation years back. I was in the planning department for a year before I went to short circuit studies group. And when this substation went online, the fault currents in the area jumped by about like 20%. So if you see construction activity from a utility in a given area, it's a good idea to investigate, hey, are you adding a substation? How's that going to impact things? And even device setting changes. You may have a device that has settings like this for a given amount of short circuit current, and then somebody changes the settings. That has a big impact on the clearing time. Why on earth would somebody change the settings? Yeah, anybody that's been around the block a time or two knows when a device trips, some people are kind of inclined to boost the settings. Don't do that. Find out why it tripped. Talk to somebody before you adjust the settings, because that can have a big impact on things. Equipment labeling. There was an addition to the equipment labeling requirements, 130.5H. You have to have the system voltage, the arc flash boundary, and at least one of the following: the incident energy and working distance, or the PPE category. There's a long history behind that one that I won't get into here. But instead of the PPE category, since you're not allowed to link it with the incident energy, do your own. Come up with what's called a site-specific level. So if you're of the time when people like to talk about category 2 and 4, just call it level 2, level 4. My preference today is to put the arc rating on the label, because that's all anybody really cares about. I don't care if it's 2.3, 3.4, or whatever. I want to know, what do I wear? 8 calorie PPE? So that's the better way, my opinion, the better way to go about it. So as a minimum, you have to have the voltage, the boundary, and at least one of the following: a method to identify how you're going to select the PPE. So the new addition for equipment labeling is the label has to be of sufficient durability to withstand the environment involved. So really important, because it can be difficult to read if you have a label that's faded out over time. You're going to see a label fade right here before your very eyes. About a 7-year time lapse on this. And that's bad, because now you're going to be able to read it to determine the information, to perform an arc flash risk assessment. That's going to be difficult. I have a method that I introduced a long time ago, and I've got articles, videos on it. That's a simplified labeling method. And the industry's slowly been starting to embrace this. That my approach is, for the arc flash boundary, just have a standardized boundary, 10 feet. It's pretty good at low voltage, because it only affects the person that doesn't belong there. If you're doing the work, you have the proper PPE and training and everything. I hope you're supposed to. And so this just says, hey, everybody stay back at least that far. It doesn't affect the people that are doing the work. And then have an arc rating of the PPE. Forget about the calculations. You still need those to be documented, but just put the PPE arc rating and then the voltage on there. And what's so great about this is, if you go back and you review the study at periodic intervals, and numbers go up or down, like it goes from 5.3 calories to 5.8 calories again, so what? 8 calorie PPE still works. Your boundary goes up or down a little bit, so what? If it's still within 10 feet, still good. You don't have to relabel. And you can put a little maintenance sticker like I show here in the lower right, just says, hey, we reviewed this, still good to go. So I'm surprised at how this is really starting to take off in the industry, and I developed it quite a few years ago. Actually had an article in Electrical Contractor magazine about it quite a few years ago as well. There's another issue, that if you have a case where you have a really large calculated incident energy, like over 136 calories here, it's extremely dangerous. So, okay, well, we better de-energize that, make it electrically safe. Great. But I have to go test absence of voltage. And if it's still energized, which has happened in a few cases, that's not going to end well. So NFPA 70E introduced some methods to reduce the risk, kind of a preliminary check. before you go in and do contact voltage testing. So this was the original language, which was changed for 2024, where what you do is basically use a capacitive proximity tester. So you're getting in proximity to basically buzz the line to see if there's a voltage. Now be careful, because these don't technically tell you absence of voltage, they tell you presence of voltage. So there could still be a little bit of voltage. So it doesn't mean that it's dead until you've used a contact device. If you can look at the equipment, see visible gaps or things are racked out, that's a good verification. Increase the working distance, back up, the energy drops substantially if you can increase the working distance. And consider alternate design methods to try to reduce the incident energy level. Hearing protection. Hearing protection has been a requirement for some time now, but the way it was written kind of took a step back and thought, we need to think about this. The way it was written, employees shall wear hearing protection whenever working within the arc flash boundary. What if somebody's in the arc flash boundary and they're technically not working? Okay, it applies to everybody within the arc flash boundary, regardless of whether they're working or not. So that person doing the work on the left, they have hearing protection. If someone gets within the arc flash boundary, well, they should be trained and qualified and be wearing proper PPE, not exactly like this guy. And I don't think sticking your fingers in your ears qualifies as hearing protection. So, gloves. There was a change in terminology to the table for gloves. And what it was, there was some confusion about a word that was known as gauntlet. And the gauntlet is the distance from the edge of the insulated glove to the protector. And like, what's a gauntlet? I mean, you start thinking back to movies where I'm going to throw down the gauntlet and challenge you to a duel kind of a thing. Well, okay, so that was changed. Instead of distance between gauntlet and cuff, add more words. Distance between the protector cuff and the rubber insulating glove, minimum. And why you have to have a minimum distance is because you have to be able to visually see that the insulated glove is there. If the insulated glove was down in the protector, you wouldn't know where your electrical insulation ends. So it extends beyond the protector just a little bit. DC arc flash. We're learning more about DC arc flash, but there's still a long way to go. And there's tables within NFPA 70E about PPE for DC arc flash, and they now and then get revised, and this is one of those times that the tables for DC arc flash for selecting PPE, there's been some new test data that says it's pretty hard to sustain an arcs below 125 volts DC for fault currents less than 17,000 amps. So the voltage, to sustain an arc over a greater distance, you need a greater voltage. So you start having lower voltages. That makes it more difficult. And the fault current, that results in the plasma, the ionizing air, which is conducting. And so if you have a more limited fault current, that makes it a little more difficult to sustain as well. This is not IEEE data. So there were two tables in the 2021 edition. One for voltages up through 250 volts, another one 250 to 600 volts. This has all been redone. We have one table based on the test data, and this table is for voltages from 150 to 600 volts. And it's broken up by fault current. So DC fault current, you need to know what that would be. Uh-oh. What do you do when the lights go out? Well, you may decide, hey, a circuit breaker tripped. Okay. What do you do when a circuit breaker trips? Well, you identify which one it is, and what many will do is just reset the circuit breaker. Simple enough. Well, no, not according to the world of NFPA 70E. That in NFPA 70E, you don't just arbitrarily reset the circuit breaker. You have to identify, why did it trip? There was language in there about repetitive, which implied, oh, well, we could try it once. We just can't do it again. Well, even trying it once, if there's a pretty bad fault out there, it may not end well. So the rules are now, you have to have a qualified person investigate, why did it trip? I had a case, my own case years ago, when I went to school at Ohio State in the late 70s. I was a co-op student at a foundry. And there were some people in the department next to us. There was an old brass foundry that had wood block floors, because when brass fittings fall, you want them to hit the wood block, not the concrete. Some people were trying to anchor equipment, drilling through this equipment, trying to anchor it to the wood block floor, and poof, the lights went out. Fortunately, we heard all the commotion and knew what had happened. The drill bit went right through the conduit, right through the conductors, tripped everything out. Had we not seen all the commotion, our knee-jerk reaction would have been, let's figure out which breaker it was and reset it. And we would have closed the breaker right back into a pretty nasty fault that they had. So that's what this is all about. You have to determine why it tripped before you reclose it. And then some language was actually changed or moved to a note. And that's about if it's been determined that this is from an overload, then okay, go ahead and just reset it if it's an overload. Chapter 3 has some really good information in it. I want to describe Chapter 3 first. Chapter 3 technically can modify the requirements of Chapter 1. And that's important to note. And a lot of the material that's in Chapter 3 was introduced by the United States Department of Energy. And one of the places where this has people scratching their heads is in Chapter 3, there were some places that were saying 50 volts to sync up with other places, but within the DOE, it's actually 100 volts. So the threshold is 100 volts, short circuit power, 1,000 watts. So there were some places where that was changed. And like in 320, AC thresholds are 50 volts, just like we have in Chapter 1, 5 milliamps, which is actually where ground fault circuit interrupters begin to trip. And then we had DC in there, 100 volts. So the initial problem was this is what we had, 100 volts. But up here, we had 50 volts. So we needed to make a change. The change was made. And then also, a threshold of current and a threshold of short circuit power was added here as well. Informative Annex O, which is about design, safety-related design concepts. There was a new addition here about high impedance protected test points, where you can measure the voltage through the door, try to minimize your exposure to the hazard. So verify voltage before you open the door. Looks like this. And then just want to make a mention, there's an IEEE standard that's in the works about a recommended practice for electrical design techniques to improve electrical safety. We're probably several years away from this being completed, but there is work on a standard to improve electrical safety. And there was a new informative annex. This is about maintenance. Condition of maintenance is used throughout NFPA 70E, but there's not a whole lot of guidance on it. So now there's an informative annex for condition of maintenance. And this is broken up into the electrical safety program should consider the condition of maintenance. And safe work practices are used when you're gathering data for the maintenance. You don't just open it up, hey, what's in here? Make sure you're using safe work practices. And verify the equipment's installed in a professional manner. And you can use testing and inspection to help with the condition of maintenance. And there's also continuous monitoring that can be used. Monitor the equipment, analyze the data, identify trends, use labels for the maintenance history or some other form of documentation. And there are standards for the condition of maintenance. Of course, NFPA references another NFPA standard, 70B, but there are also NETA standards about maintenance. So, wow, this is amazing. 2024, we're just rolling this out and people are coming up to speed with it. But the thing is, things move so fast before you know it, 2027 is going to be out, right around the corner. The timeline for 2027, and I'm saying this so that you can get involved. Me? You. So the timeline, there is now a call for public input, basically proposals, and it closes next June. So we're a little over 6 months away from the closing of this. So if you have things you'd like to see different, added, deleted, changed, whatever, go to nfpa.org and you could find the process for submitting your proposal. And then I'll be one of the ones that gets to read it sometime next summer. And who knows where it'll go. And then there'll be a first draft report that'll come out in March of 2025, the following year. And that will lead to a second draft with public comments due June 2025. And then another meeting, and then another report, 2026. And then speak now or forever hold your peace. Motions for possible like final changes. It's called notice for intent to make a motion. That's kind of the last step. And then before you know it, we're going to be doing this all over again with the 2027 edition. So, number one, I would like to thank our host and sponsor for this. Number two, please keep in touch. These are all the various ways that you can keep in touch with me: my email, LinkedIn, YouTube channel, ArcFish Forum. And what I'd like to do now is take a look at some of the questions, except I am going to have to defer to Colleen to tell me, tell me where these questions are. So Colleen, if you could jump in here and maybe direct me where I'm going to.
Sure, there should be a Q&A box on the right of your screen, Jim. If you don't see that, I can direct some questions to you.
It would be this box. Oh my gosh, I shouldn't have asked.
We had several questions about your video, if you want to start with those.
Okay. Let me head down here to the bottom. Is a PDF copy of the presentation available? No, not from, no. I try to keep my hands on the slide because this is all I do. So I can't give it all away because this is what I do for a living. But there will be a video, as Colleen mentioned, and I have a video. I presented this earlier this year for us in our studio here. And what we did is we chop it up into modules and actually make an on-demand training program out of it where you can take a quiz, get CEU credit, all that stuff. So basically all this is out there. You can either wait and Colleen can set you up with a recording of what we did here, or go out to brainfiller.com on-demand training. Is PDH certificate available? I don't know about from the magazine, but as I said, from us, if you go out, take the quiz. The slides are not changing. I hope that was fixed.
I took care of the technical stuff.
Okay,
Anything
yeah,
that's put out, yeah.
Yep, got it. Okay. Here's a really good one. There's currently a lot of virtual training replacing in-person training. Does virtual training satisfy all the requirements? Everything but hands-on. If you need hands-on to demonstrate skills and all that, it's hard to do that virtually. But yeah, it was the 2021 edition of NFPA 70E for training. Says it could be classroom, on the job, or I think it uses the word computer-based training, virtual training. And that was before the pandemic. I mean, 2021, we were right in the middle of it, but that language was actually submitted before the pandemic. And then when that happened, I was like, wow, somebody thought this through. Then we'd actually start switching over to virtual beforehand anyway. So yeah, according to NFPA 70E, computer-based training is acceptable unless you need, the hands-on, somebody, visually verifying that you're doing the tasks correctly. Let's see here. Does regular maintenance of electrical equipment in normal operation require documentation of maintenance per manufacturer's recommendations or NFPA 70B requirements? Documentation is something that you want to do in case something goes wrong. As I mentioned, I've been involved with legal cases in the past, expert witness type of work, and everything comes under the microscope. Well, we just operated. We weren't wearing PPE. Well, it blew up. Well, did you go through all, the boxes properly maintained and all that? So documentation is incredibly important, mostly as a defense mechanism and also just as record keeping. So you know when you've done certain things to the equipment. What voltage and available fault current did I use to blow the doors open? Oh, that was, we were using both 480 volts and 600 volts for those tests. And some were at 600 because we wanted to make sure that the arc would sustain. Otherwise, you just get a pop and it goes out. The fault current for that series of tests, I believe, was 18,000 amps. So in the grand scheme of things, it was a reasonable fault current, but it wasn't excessive. So it depends on the design of the equipment. And actually that small box where the cover blew open, it sheared the hasp off. So the door kind of blew open because the hasp that it was over just ripped the thing off. You probably couldn't see it in the video, but when I went through the analysis. So and you can't tell because unless you have arc resistant equipment, it's not designed to guarantee that it's going to stay closed. So it's a big unknown. What was the voltage system? Oh, okay, same question. Yeah, it was, I think those were 600 volts, I think. 480 or 600, and then 18,000 amps. Let's see here. Were the doors fastened shut with appropriate hardware? They were fastened shut with whatever was they were equipped with. 70E identifies minimum content that must be on an arc flash label. I assume this must be printed on the label. Is it acceptable for it to not be printed on the label, but rather a unique QR code, which then takes personnel to the content? I don't recall seeing anything. You can have a QR code, but to replace the information on the label, the only thing that I'm aware of about no information on the label is an exception. That if you have a qualified industrial installation with qualified workers, then you can document the results, basically a study, and not put anything on the label. But it's meant to be if you have a really complicated system, where if it's in this configuration, the incident energy is this value. If it's in that configuration, the energy is this value. It's like, what do we put on the label? Well, let's put it all on the label. That's not going to work. Well, let's use multiple labels. That's a bad idea, too. Let's put the worst case on there. I live in Phoenix. It was 119 this summer, and we had like 40-some days above 110. No, let's not put the worst case on the label. So that's the only exception that I'm aware of in that case. Do I recommend the use of insulating carpets? I actually don't recommend anything on purpose for really legal reasons, things like that. I can't make interpretations or recommendations. It couldn't hurt. I'll leave it at that. Let's see what else we have here. What about the changes that require infrared testing? I'm not sure what you mean by changes that require infrared testing. Infrared testing is a good PM kind of a thing. When you perform infrared testing, be trained, be qualified, adhere to NFPA 70E, requirements. If you're opening the doors, that's interaction, those types of things. Did I get them all? Bear with me here for a moment. Make sure I got them all. Let's see here. Oh, 70E went to 1,000 volts. When will 70? NFPA 70 went to 1,000 volts. When will 70E make that jump? Actually, if you look in the PPE tables for 70E, they have voltages higher than 1,000 volts. So it's kind of there. Will 70E be available in Spanish? That is up to NFPA. I know there's one guy on here, I recognize the name, that may know that one. I don't know of any plans to convert it to Spanish, or maybe it has been and I just don't know. Do I do private consulting for contractors? I don't do consulting as like an hourly kind of a thing. I do training at different locations. I do that. I think that was it. Colleen, do you have anything to add, or you want to wrap it up for us?
Yeah, we're just about to the hour, so this is a good time to wrap it up anyway. So I just want to thank everyone for attending on behalf of Electrical Contractor Magazine. A big thank you to Jim for such a fantastic presentation, and a big thank you also to our sponsor GlenGuard for generously sponsoring this webinar. Please don't forget to fill out the survey. It's going to pop up on your screen when the webinar ends. It's just a couple of quick questions. And be lookout in your email for the recording of this event. So I know Jim went through a lot of information, so you can always come back to that recording and watch whatever parts of the webinar you'd like, including the whole thing. That should be available in just a few hours. And if you all enjoyed this webinar, please feel free to forward that recording email to anyone else that you think would benefit as well. We always love to get new viewers. So I hope everyone has a great rest of the day. And I hope to see you at the Construction Outlook preview webinar in a couple of weeks.
One last comment from me. Thank you all for being here. This was great. Looks like we had quite a turnout. And really, I should have said this early on. Thank all of you who participate in the NFPA process. It's the input, the efforts of all of you. It's the efforts of all the volunteers on the 70E committee. I mean, it's a lot of people that make this happen, and thanks to all of them. Thanks to all of you for being here. And thanks to Electrical Contractor for having us.
All right. I hope everyone has a great rest of your day.